This is again a MSQ question. Which of the following statement is true for a BJT with respect to its DC current gain beta? Okay, let us discuss this question. So let us find out the options one by one. Under high level injection condition, in forward active mode, beta will decrease with increase in the magnitude of the collector current. Okay, magnitude of the collector current. So the practical graph between current gain beta and the collector current is like this, okay, IC and current gain beta. So this graph is like this, and this drop region here, where current gain is decreasing with increasing collector current, is due to high level injection. High level injection means the charge carrier which are injected from emitter into base are very very high, and due to this sometimes what happens, the injected charge carrier concentration, which is basically minority in the B region, in the base region, becomes the concentration of that injected charge carrier, which is basically minority for the base region, but its concentration becomes higher than the concentration of majority charge carrier in the base region. And under this high level injection condition, what we found that with increasing collector current, the current gain beta decreases. So option A is absolutely right. Option A is absolutely right. With high level injection, with increasing collector current, the current gain beta decreases. That is absolutely right. Okay, so option A. Now let us find out option C and D. I will come later, hai na? Okay, so beta will be lower when the BJT is in saturation region compared to when it is in active region. This option is absolutely true. Why? Because in case of active region, beta is nothing but active region is IC upon IB, and if you increase IB in the same ratio, IC will increase. If you are in active region, with increasing IB, IC will increase by a factor of beta into IB. Okay, so this current gain remains constant in active region, hai na? And its ratio is always IC by IB. But what happens in saturation region, if you will find out the beta, so that will be IC set upon IB. In saturation region, if you will increase IB above IB min, when IB reaches to a value of IB is equal to IB min, then current gain becomes, then your transistor enters into saturation region. When increasing IB reaches to a minimum value called as IB min, your transistor enters into saturation region, and if you increase IB above IB min, your collector current will not increase and it will remain constant at IC set. It will saturate. Okay, so in saturation region you keep on increasing IB, but your IC set remains constant, so your beta decreases. Okay, so in saturation region your beta will always be lesser than compared to active region, because this is not increasing, this is denominator is keep on increasing. What was happening here, if you will increase IB in the same ratio, IC will increase, so that this ratio remains constant. Okay, but when here collector current gets constant, hai na, and you are increasing IB, with increasing IB your IC is not changing, and this ratio therefore is decreasing, and therefore in saturation region your beta will always be lower than the value of current gain beta in active region. Okay, so this option is also correct. A higher value of beta will lead to a lower value of the collector to emitter breakdown voltage. So collector to emitter breakdown voltage beta VCEO is nothing but breakdown voltage, collector to base breakdown voltage divided by nth root of okay beta, where nth n is called as empirical constant. Okay, its value mainly lies between 3 to 6. Okay, now what this option says, if you increase beta, what will happen? A higher value of beta will lead to a lower value of the collector to emitter breakdown voltage. So beta VCO is collector to emitter breakdown voltage. So if at higher value of beta, obviously this denominator will be higher and this ratio will be lower. You will get a lower value of if it is high, obviously it will be a low value, because denominator is high, this ratio will be low, and therefore collector to emitter breakdown voltage will be low at lower value when beta will be at higher value. So this option D is also correct. Now this option B is under low level injection condition in forward active mode, where the current at the emitter base junction is dominated by recombination generation process, beta will decrease with increase in the magnitude of the collector current. No, beta will definitely, you can see from this graph, beta will increase. Here recombination dominates, okay, है ना, here recombination dominates. Okay, so this is the case of low level injection, where with increasing collector current your beta is increasing, not decreasing. This option is saying that under low level injection. So this part of the graph was under high level injection, this part of the graph was in case of under low level injection. So you can clearly see that, है ना, under low level injection, the with increasing collector current your beta is increasing, not decreasing. And this option is saying under low level injection condition in forward active mode, where the current at the emitter base junction is dominated by recombination generation process. So in case of low level injection, recombination generation process dominates. Okay, the carrier which are injected in from the emitter into base, they are getting recombined, and the charge carrier which is not getting recombined will be transferred to the collector, and from where we get the ratio IC upon IB. So under low level injection, beta will decrease with increase in the magnitude of collector current. No, beta will increase with the increase in the collector current. You can see that with increasing collector current you are getting higher value of beta. Here with increasing collector current, x is increasing, y is decreasing. Here x is increasing, y is increasing, है ना? Okay, so this option is therefore wrong. Okay, so option A, C, D are correct. Option A, C, D are correct here. Okay, only B option is wrong. This was the MSQ question. So let us discuss the next question. Okay,